All right. So that is what we would like to cover as far as rivers and streams are concerned. Now we begin to look at wind actions and deserts. Wind actions and deserts. So we want to talk about wind as a geologic agent. Wind is common everywhere, especially in desert areas or arid, which means dry, arid desert regions. Why is this so? One, the air that is very close to the surface is heated and then it's going to rise. And as the air that is near the surface gets heated, it becomes very hot and it rises. We know that cooler air is going to come in to replace that hot air. And so this movement of air results in winds. So hot air gets heated and rises, cooler air is going to come in to replace the hot rising air, and then the cycle continues. So we are having winds. So these dry regions or arid regions do not have soil moisture. They have little or no water in the soil. So very little soil moisture, and such that it's not able to hold the rock and then the soil fragment, the mineral fragments. So because of this, we see that wind has the ability to transport, to erode, and also to deposit. So just like the river, we saw stream had the ability to transport, to erode, and to deposit. So wind also has the ability to transport, to erode, and to deposit sediments. So now we want to talk about wind transport. Wind transports sediments near the surface by the process called saltation. And under streams and rivers, we met this act of saltation, and we call this short jumps. So saltation refers to short jump of particles that are removed from the surface and then jumping by a short distance. So they are removed, small particles are removed from the surface and then they jump a short distance. So these small particles can become suspended in the wind, and then they may travel for very long distances. So this is the process of saltation. We see from here, we have a jump to this point, then another jump, that's saltation. Then if the particles are very tiny, like dust particles, science-sized particles, they can be carried, and that is suspension. Down here, we could have slow rolling movement, and that is creep. All right. Sand could also form, we could also have sand ripples, and this occur as a result of the bigger particles getting accumulating as smaller grains are transported away. So then we are going to form a ripple. And ripples form in lines perpendicular to the wind direction. So we have ripples. We could also have wind-blown dust. So sun-sized particles, we know generally are not going to travel very far in the wind. But if you have very tiny fragments, then they can be suspended in the wind for a very long distance. So that is wind-blown dust. As far as wind erosion is concerned, we know that wind can be a very effective agent of erosion, so long as it is strong enough to act. And wind can erode by two processes. The first is by deflation, and the second is by abrasion. Deflation and then abrasion. So deflation, to deflate means something is coming down, right? It's reducing. So deflation is the lowering of the surface of the land, and this is because or due to the removal of fine-grained sediments or particles by the wind. So this deflation is going to cause bigger grained particles or bigger sized particles to remain at the surface, and then the smaller particles are transported away. When this continues and continues, then we are going to have a lowering, a reduction of the initial level of the level, the soil or the ground, and that is called wind erosion by deflation. So this is a process. So the fine particles are being blown away. We are left with only bigger particles. Ultimately, we are going to form this kind of material or layer we call the desert pavements, consisting of generally coarser grained particles, and this is a desert pavement. Desert pavement, but we see the original ground level has reduced considerably. Then we could also have, we said wind can either erode by deflation or abrasion. So in terms of abrasion, we could have the formation of ventifacts. Ventifacts. A ventifact is simply any bedrock surface or stone that has been abraded or shaped by wind-blown sediments in a process similar to sandblasting, which is just forcing a lot of sand to abrade or to clean out a piece of metal, sandblasting. So here we see the wind direction. So the particles come and hit and chip away the surface of this particular rock or outcrop here. And it's abrading the surface, so we form a ventifact. So this is a typical ventifact. So any bedrock surface that has been abraded or shaped by wind-blown sediment is called a ventifact. Then we have yard dams. So yard dam, this is an example of a yard dam. So these are streamlined wind-eroded ridges. So, and these are commonly found in deserts. And this consists of a sharp, irregular ridge of sand lying in the direction of the prevailing wind and typically found in exposed desert regions. And this happens when the adjacent material does not have a lot of resistance to the wind, such that it erodes, but then the material remaining is much more resistant, and so it stands, and that is called a yard dam. Whereas a ventifact has to do with any rock surface that is abraded or shaped by wind-blown sediment. So now we know that we can also have deposition, right, by wind. We've looked at wind transport, we've looked at wind erosion. Now we are looking at the deposition of wind. So wind can deposit sediments when its velocity reduces, just like in the case of streams. So if the velocity of the wind reduces such that the particles can no longer be transported, then of course deposition has to occur. And this can happen when we have topographic barriers like a mountain on the downwind side or along in the path of the wind. All right, then we can have this part of this type of deposition. So when we talk about a topographic barrier, it can be a tall building, it can be a rock, it can be vegetation, anything that rises or protrudes above the land surface is a topographic barrier. So as the wind travels, it gets to this point, it tries to rise above the barrier. It's going to cause it to reduce in velocity, and it has to deposit just after the barrier. We are going to have these huge deposits of sand. So the right here is a topographic barrier. So due to these topographic barriers, we can end up forming different types of wind deposits, such as sand dunes. So sand dunes form when there is a ready supply of sand, a steady wind, and then we have some kind of obstacle, rock, vegetation, or fence to trap some of the sand. So then the sand dunes form when the moving air slows down on the downwind side. That is, immediately it leaves the topographic barrier, the downwind side. The sand grains will drop out, and then they are going to form a dune. All right, they're going to form a dune. Here we have a sand dune, and this is the cross-sectional area of the sand dune. All right, this is a cross-sectional area of a typical sand dune. All right, then again, we could have these different types of sand dunes. Here we have a backhand dune, linear dune. So here we have the wind in one direction. We have a backhand dune. We have a transverse dune, parabolic dunes, star dunes, and this is a backhand dune that is becoming a transverse dune. Backhand dune becoming a transverse dune. Backhand dune becoming transverse dune. So we will now look at this one by one quickly. So when we talk about a backhand dune, it's like crescent shape. And the crescent is going to point in the downwind direction. This is the wind direction. This upwind direction. And this side is downwind direction. Upwind direction, downwind direction. So the crescents are pointing, the shapes are pointing in the downwind direction. And it's just like a curved slip surface, curved surface, curved slip surface. And then they form in areas where there is a hard ground surface. And we have a moderate supply of sand and then a constant wind direction. So these are typical examples of the backhand dunes, the backhand dune. Then again, we could have transverse dunes. Transverse dunes. And these are large fields of dunes that resemble sand ripples. So we see the shape is like sand ripples on a large scale. And it consists of ridges. It's like a ridges of sand with a steep face in the downwind direction. They have a steep face in the downwind direction. And they form in areas where there is abundant supply of sand in a constant wind direction. Whereas the backhand is forming in a moderate supply of sand. The transverse forms in an abundance of sand. The backhand dune can merge into transverse dune. So if these ones merge, they are going to form a transverse dune if the supply of sand increases. Then we can have linear dunes. Linear dunes. So in the case of the linear dunes, it consists of long, straight dunes that form in areas with a limited sand supply and converging winds. So you see, there are two wind directions in the formation of a linear dune. We have this one and this one. So they converge or meet, and it forms this kind of shapes, these long, straight dunes called linear dunes. Then we could also have parabolic or blowout dunes. These are U-shaped, U-shaped. Whereas the backhand are crescent shapes, the parabolics are U-shaped. And we have the open end facing the upwind. The open end is facing the upwind direction. And these are usually stabilized by vegetation that is present. So it occurs where we have an abundance of vegetation, a constant wind direction, and then an abundance on supply. We typically could find this in coastal areas. All right, the parabolic dune. Then when we have wind flowing or blowing in many directions, we could have this star dunes, like a star shape. So we should have wind blowing from different directions and depositing sediments to form the star dune. Star dune. So wind has to flow from different directions to form the star dune. Then we could also have wind-blown dusts. So as far as wind-blown dusts are concerned, dust we know consists of silt and clay-sized particles that are often packed together with smooth surface. So a large deposit of wind-deposited dust is called a loess. A loess. All right. A much loess was derived from a debris left by glacial erosion. So that's a large deposit of wind-deposited dust. Now, we could also have dust in ocean sediments and glacial ice, because dust can be transported by the wind and by glacial ice onto the surface of oceans. So we could also look at, as a result of this particular transportation of dust, much of the fine-grained continent-derived sediments is able to reach the abyssal plains of the oceans. And this particular sediments or particles of dust we find in the abyssal plains were originally transported by winds or icebergs. So this end up in the abyssal plains, which is a When we talk about the abyssal plain, it's just more or less a special plain at sea. All right. So that is an abyssal plain. Abyssal plain. All right. Abyssal plain. All right. So these are very deep portions of the sea. We have the abyssal plain. All right. From the word abyss, right? Abyss. All right. Then we know that wind can also transport volcanic ash. So during explosive volcanic eruptions, we can have large quantities of tephra, that size tephra, can be ejected into the atmosphere. If this is ejected high enough, the ash can become suspended in the wind, and this can be transported for very long distances. Eventually, the wind will deposit the sediments, and that can form volcanic rocks like tuff.